Today we're going to be looking at solving quadratic equations by taking square roots, lesson 3.1. Now, as we're doing this lesson, please feel free to hit pause at any time and rewind on areas where you need to hear it again, or if you need to take time to try a problem yourself. So today we are going to be doing the first three parts of 3.1. We will do explain 4 on Tuesday. Solving quadratic equations by taking square roots. We are asking ourselves, what is an imaginary number and how is it useful in solving quadratic equations? Back in Algebra 1, your teacher has always told you, you can't take the square root of a negative, that's no real solution. That is no real solution. Well, today we'll be looking at when there is a non-real solution. So first thing we want to do, we want to look at 3 different ways to solve a quadratic equation. The first way to solve a quadratic equation is by graphing. If I'm graphing, I treat my two sides of my equation as separate functions. So I call the left of my function f of x, and I'm going to call the right of my function g of x. Okay, and I'm going to graph each of them and see where they intersect. So the graph of g of x equals 16 is just a horizontal line through 16. X squared, well, x squared means I take each of my x values and square it. So 0 squared is 0. These are counting by 2's. So 2 squared is 4. 4 squared is 16. So there's my my right of my parabola, and then I can reflect it over, because negative 2 squared is 4, negative 4 squared is 16. And we ask ourselves, where do these intersect? So it intersects at the point 4, 16, and negative 4, 16. That means those x values are my solution to my quadratic. So negative 4 and 4 are the solutions of where x squared equals 16. Of where x squared equals 16. So that's what it looks like visually. Next, let's look at factoring. With factoring, I could factor and use the zero product property to set each factor equal to 0. To factor, you first need to make sure the equation is equal to 0. So we subtract 16 from both sides. I get x squared minus 16. Now x squared minus 16, this is the same as x squared minus 4 squared equals 0. Because 16 is a perfect square. So when I have a square minus a square, that's a difference of 2 squares. Back to Algebra 1, the rule for a difference of 2 squares is that if I have a squared minus b squared, then I get a plus b and a minus b. So a plus b times a minus b is the same as a squared minus b squared. So since 16 is 4 squared, I get x plus 4, x minus 4. And then I could set each factor equal to 0. X plus 4 equals 0, x minus 4 equals 0. I isolate the variable, so x equals negative 4. I isolate the variable by adding this time, so x equals positive 4. So my potential solutions are x equals negative 4 and x equals 4, which notice it matches what we got when we solved for square roots, or solved by graphing. And so now we're going to solve with square roots. Now any square root of a non-negative real number, okay, will be a real number. Okay? And so, square roots are written with the square root symbol. It undoes squares. And every square root has a positive square root and a negative square root. The negative is written outside. So for example, the square roots of 9 are plus or minus the square root of 9, which is 3. So plus or minus 3. Now 0 is a unique one that only has one square root, because positive 0 and negative 0 are the same thing. So if I have x squared equals 16, I take the square root of both sides, but I look at the positive and negative case. And the square root of 16 is 4, so I get positive and negative 4, which matches my previous two solutions. It's just written as a single item when I write it as plus or minus. That does mean both the plus and the minus solution. So hit pause and ask yourself which of the three methods would you use to solve x squared equals 5. Okay, and then solve using that method. Please hit pause now. Now if you tried graphing, you would have noticed that they would not intersect at whole numbers. If the graph doesn't intersect with whole numbers, then you're just estimating where it is. If you try to solve by factoring, 5 is not a perfect square. So there is no perfect square amount that you could use. So I would recommend by using square roots, because that can give us an exact answer. That can give us an exact answer with not just an estimate of what it looks like. Because I go and I take the square root of both sides with the plus or minus, and I get x equals plus or minus, and you ask yourself, can the square root of 5 be simplified? Well, 5 is a prime number, so it is just the square root of 5. All right, moving on. There are two properties that are going to be important as we're solving. There are going to be two properties that are very important as we're solving. The product property of square roots and the quotient property of square roots. The product property of square roots tells me that if I have the square root of multiplication, then I have the square root of two separate multiplications. So you can break apart square roots over multiplication. The quotient property of square roots tells me I can break apart square roots across division. So I could separate the numerator and denominator with separate square roots. Keep in mind this only applies to multiplication and division. You cannot break a square root apart across addition. If you have the square root of a plus b, this does not ever equal the square root of a plus the square root of b. Do not break that apart. That does not work. But the property of multiplication works and the property of division. Alright, now one more thing. You did this in geometry, but I know it's been a year. You need to rationalize the denominator, rationalizing the denominator. Okay, so if in your denominator you have square root, you need to make it so that you have a rational number, not a square root. And so we do that by multiplying by a pair of ones. And so we do that by multiplying top and bottom by the same number. So you multiply top and bottom of the fraction by whatever the radical was in your fraction. So by doing that, the square root of 2 times the square root of 7, well, I can use my product property of square roots and to get the square root of 2 times 7, which is square root of 14. In the denominator, the square root of 7 times the square root of 7, well, 7 times 7 is 49. I get the square root of 49. And this simplifies for us because the square root of 49 is a whole 7. So notice the square root of 7 times the square root of 7 became a whole 7. Okay, the square root of 7 times square root of 7 was square root of 49, which was a whole 7. And so this is now a rationalized fraction. This is now a rationalized fraction. So to solve an equation by taking the square root, you want to work on getting your variable by itself. So on this one, you're trying to isolate the 2x squared. You always isolate the whole term with x first, so you move any terms that don't have x. So I'm going to add 16 to get 2x squared equals 16. Now that the term is isolated, I now get rid of multiplication. So I'm going to divide both sides by 2. 16 divided by 2 is 8. I take the square root of both sides, so I get x equals the square root of 8. Well, 8 can simplify. 8 is 4 times 2. So you could write it as the square root of 4 times the square root of 2. I'm going to just continue my factor tree, and 4 breaks apart to be 2 times 2. So I have a pair here, so I have 2 squared. Well, the square root of 2 squared is a whole 2. So these square roots of 2 become a whole 2. And this 2, well, he's just by himself. He's not a square, so he stays inside. So square root of 8 becomes 2 square root of 2. Okay, so on B, I want to isolate my x squared term first. So to isolate that x squared term, I subtract 9 from both sides. And I get negative 5x squared equals negative 9. I'm trying to get x squared by itself. So I divide both sides by negative 5. A negative over a negative is a positive, and I have positive 9 over 5. I want to apply the square root, so I get square root of 9 over 5. Well, this breaks apart, the square root of 9 over the square root of 5. But what is the square root of 9? The square root of 9 is 3 over the square root of 5. We are not done with this problem because this problem is not rationalized. There is a square root in my denominator. So multiply the top and bottom by the square root of 5. Now this 3 and 5 cannot multiply because the 3 is not in a square root. Okay, they only multiply if they are both square roots. Okay, so they stay like 3 times x. So it's 3 times square root of 5. All over. The square root of 5 times the square root of 5 is the square root of 25, which is a whole 5. Now I dropped something on this last step, so I'm going to go put it back in. Plus or minus. We've got to consider both the positive and the negative solution. Plus or minus 3 square root 5 over 5. So at this point, I encourage you to pause the video to try 3 and 4. Take a minute to pause the video, but don't give yourself longer than 2 minutes per problem. So go ahead and pause the video, and then when you're ready, hit play again to check your answers. Pause now. So when you check your answers, make sure that you add a 24 to both sides. And then when you square root it, you have to ask yourself, can 24 simplify? That's 12 times 2, that's 6 times 2, that's 3 times 2. So let's see, there's a pair of 2's. So I get 2 on the outside. I get a 2 on the outside. Square root, and on the inside are these guys. They're still left behind. But what is 3 times 2? 6. So I get 2 square root of 6. So x equals plus or minus 2 square root of 6. As you check your answers on number 4, subtract 13. Divide by negative 4. 2 negatives make a positive. I go and take my square root. And so now the square root of 13 is just the square root of 13. The square root of 4, though, is 2. Notice that is a whole number in my denominator, so this is already rationalized, so that is my answer. That is my answer. We're going to look at some real-world situations that involve square roots. Okay, they're going to involve 2 formulas that relate to gravity. The gravity constant on Earth is negative 13 feet per second squared. And so the way we model that, we model the effect of gravity on a falling object, is by gravity over 2 times squared. And so gravity over 2 is 16. So when you see 16 in problems, that is the gravity constant in feet per second squared. The gravity constant can also translate to other units. So you may sometimes see it in other units, and it won't be 16 if it's a different unit. Again, this gravity constant applies to Earth only. Okay, if we're talking about a different planets have different gravities because of their distance from the sun and the speed of their spinning, and those factors affect the amount of gravity on them. Alright, so first formula is distance fallen of a object, and we are considering that no air resistance. We are assuming no air resistance. So this would be if we were dropping the objects in a vacuum. I know real world, there would be air resistance. So those of you in physics, yes, the real world has air resistance. But for the sake of these problems, we are going to be assuming there is no air resistance. If there's no air resistance, all objects will fall at the same speed. Okay, if objects only fall at different speeds, if there's air resistance, that is pushing back on the object. So distance fallen can be represented by distance is 16 times time squared. 16 times time squared. The distance is in feet, and the time is in seconds. Now the height of an object at any given time, the height is whatever the starting height. So notice h of 0 is initial height. So it's the starting height minus that distance. So it's the starting height minus the distance fallen. Starting height minus 16t squared. So keep these formulas in mind for a future problem. So we're going to walk through A quickly and then do B together. So if we're dropping a water balloon, okay, we want to see how long it takes it to fall 4 feet. We take our formula of 16t squared and set it equal to 4. You try to isolate the t squared, so we divide by 16 to get 1 over 4. You take the square root, and the square root of 1 is 1, the square root of 4 is 2. Now, it does have plus and minus as you're solving the equation, but now we have to put it back into context. Context means back into the real world situation. And in the real world, we're not going to have a negative time. Now, there will be quadratic equations we solve where both solutions make sense. But in this situation, the negative time does not make sense. Okay, so we're going to reject the negative value. We're going to say the water balloon falls 4 feet in half a second. So that is what this means in context, that the water balloon falls 4 feet in half a second. So let's look at this one. Now we're going to actually drop the water balloon off of a 50 feet building, after 50-foot building. Okay? Then we're going to figure out how long does it take for it to pass by a third-story window at 24 feet. Okay, so my starting height, this here is my h0. That's my starting height. 24 feet is what my h of t is going to be. That's the height I want to reach. So I want my output to be 24 feet. My starting height, though, is 50. So when I plug it into my height formula, my h0 is 50 minus 16 times squared. I don't know how long it's been falling. And we want that height to be equal to 24. So our goal is to isolate the term with t squared. Notice that the term with t squared is a negative 16t squared. So to isolate, we need to move the 50. The 50 is positive, so I will subtract the 50. And 24 minus 50 is negative 26. I want to isolate the t squared. So to isolate the t squared, I divide by negative 16. A negative over a negative is a positive. 26 over 16, divide by 2 is 13 over 8. Okay, so now I take the square root. Well, the square root of 13 is just the square root of 13. And 8, that's 4 times 2. And 4 is 2 times 2. So I have a pair here, so I get 2 radical 2. So I get square root of 13 of 2 over radical 2. Now I want to rationalize this, so I multiply by the square root component only in the denominator. So I multiply top and bottom by the square root of 2. So I get plus or minus square root of, since they're both square roots, they can multiply. 13 times 2 is 26. Down here, this 2 here, He's still there. And radical 2 times radical 2, well, that becomes radical 4. But what is the square root of 4? The square root of 4 is 2. What is 2 times 2? 2 times 2 is a whole 4. Okay, so this is a real world scenario again, so I'm going to consider time to only be positive. So I'm going to reject the negative value and say that the water balloon passes by the third story window of 24 feet at a time of square root of 26 over 4 seconds. And we could type that in a calculator to get an approximate answer that I believe is about 1.27 seconds. Alright, so I'd like you to try number 7. So try number 7, pause the video now. Alright, so notice this one you were using a different formula. We're using a different formula because we are on the moon, and the other formula applies to Earth. So this time gravity is 8/3. 8/3. So a lot smaller than the gravity on Earth. Okay, so I have 8/3 t squared, and I want to figure out how long it takes it to equal 4. So how did you get rid of your fraction? Well, hopefully you multiplied by the reciprocal. Hopefully you multiplied by the reciprocal. If I multiply by the reciprocal, I get t squared equals, and this 4 is over 1. I can simplify fractions, so 4 goes into 4 one time, 4 goes into 8 two times. 1 times 3 is 3, 1 times 2 is 2. So I get t squared equals 3/2. I take my square root, so I get plus or minus the square root of 3 over 2. Well, that becomes plus or minus the square root of 3 over the square root of 2. I'm going to rationalize my denominator, so I multiply top and bottom by square root of 2. So I get plus or minus the square root of 6 over, well, that's the square root of 4, which is a whole 2. I need to put it back into context. So I'm going to say that it takes, and I'm going to only consider the positive answer, root 6 over 2 seconds, for the tool to drop 4 feet. Alright, so keep in mind, when you put it back into context, you're going back to the real world situation and putting in your units and talking about what the objects are. Okay, last part of our lesson for today. As promised, imaginary numbers. As promised, imaginary numbers. So we already know previously that x squared equals 1 has 2 real solutions. We know when x squared equals 0, we have 1 real solution. And previously we were told that if x squared equals negative, it has no real solutions. That is true that it has no real solutions, but it does have imaginary solutions. So imaginary numbers are the square roots of negative numbers. They can all be written as a form of bi. Okay, we represent it as bi. And so b and I each have their own components. b is considered our real number component, and I is our imaginary unit, which represents square root of -1. So keep that in mind. I represents square root of -1. So I equals square root of -1. So in 2i, 2 is a real number, and I is our imaginary component. -5i, -5 is our non-zero number, I is our imaginary component. -I over 3 is the same as -1/3 I, so -1/3 is our b, and I is our imaginary unit. Now if you have a radical, we usually put our I in front of the radical. That way it makes it very clear that it is outside the radical and not under it. Okay? Now since I equals -1, I squared would be the square root of negative 1 squared. Well, remember, square roots and squares are inverse operations. So these two are going to cancel each other out, and you're going to be left with negative 1. So I squared is that only time where you finally have something squared equaling a negative value. So I squared equals negative 1. So if I want to find the square of these imaginary numbers, okay, if I square 5i, the square distributes to everything inside. Remember, we can distribute exponents across multiplication. That is our power of a product property. But you cannot distribute it across addition. So this exponent does distribute if there's multiplication. So it becomes 5 squared and I squared. 5 squared is 25. I squared is negative 1. 25 times negative 1 is negative 25. So please remember this. I squared is negative 1. Okay, if I have negative I square root of 2, well, that negative in root 2, that's the real number component. The negative squared, a negative squared is still, it becomes a positive, and square root of 2 squared, well, that's 2, because that becomes the square root of 4, which is 2. I squared is negative 1. 2 times negative 1 is negative 2. Okay, so pause the video, quickly try 9 and 10, and then unpause to see your answers. Pause now. Okay, so I'm going to square 2i, so I get negative 2 squared, and I get I squared. And so negative 2 squared is 4, and I squared is negative 1. So 4 times negative 1 is negative 4. Hopefully you're starting to notice that all the answers are ending up with the same sign. Whether they started out positive or negative, all the answers are ending negative. Even though they are being squared, all the answers are ending as negative. And that is because I squared is always negative 1. Alright, so we have root 3 over 3i, and we're going to square it. So that's radical 3 over 3 squared, I squared. Now when you have a fraction being squared, okay, that's a quotient that deals with the product of a, the power of a product property. Okay, there's also the power of a quotient property. Okay, so it becomes radical 3 squared over 3 squared. So the square goes to both the numerator and denominator. And radical 3 squared is 9, and 3 squared is 9. Sorry, that's a big mistake. Big oopsie. Radical 3 squared is the square root of 9. And what is the square root of 9? The square root of 9 is 3. 3 squared is 9, and I squared is negative 1. I simplify this fraction to get negative 1/3. That's it for today. Please look on the board for your homework assignment.